Hey guys, Mr. Backberg here. In this video, we're going to look at solving triangles of the form angle-angle-side and angle-side-angle. Now we know using trig is a good way to work with right triangles, especially if we're trying to find a missing side or a missing angle of a right triangle, but we can also use some trig stuff to help us out even if we're dealing with non-right triangles. So what we're going to talk about here is the law of sines, and this will work for acute triangles and obtuse triangles. So what we've got in our picture is we've got our angles labeled with capital letters. So I've got capital A, capital B, and capital C. Across from those angles, we've got some sides, which are labeled in lowercase letters. So across from angle A, we've got side A. Across from angle B, we've got side B. And across from angle C, we've got side C. Now, there's actually two different versions of the law of sines, and it kind of depends on what you're doing. I personally always like to have my variable on the top of the equation. I think that makes the solving a little bit easier. So depending on what you're solving for, one of these forms might be more useful than the other form. So in order to use the law of sines, what we're going to be doing is setting up some proportions. And what we're going to work with are a comparison with the angles and the sides. But since it's the law of sines, we're going to be doing the sine of our angles. So we can do the sine of angle A divided by the length of side A. And that's going to equal the sine of angle B divided by the length of side B, and that's going to equal the sine of angle C divided by side C. Now, depending on what information we have and what information we're solving for, we don't need to use all three pieces of this. We would just use two of them. Now, I said there was two forms to the law of sines. The other form is just the reciprocal of all these. So we would take side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. And again, like I said, I always like to have my variable on the top, so depending on if I'm solving for an angle or if I'm solving for a side, that kind of dictates which form I'm going to use. Now right now we're going to be focusing on triangles where we're given two angles and a side. So it's either going to be of the form angle-angle-side, where it's a non-included side, or angle-side-angle, where the side is included between the two angles. There will be a third case that we'll look at in another video. So as we're taking a look at this first example, we're given angle A as a 36-degree angle, we're given angle B as a 48-degree angle, and we're given side A as a length of 8. And we're going to solve this triangle, meaning that we're going to find all the missing pieces. So we need to find angle C, we need to find side B, and we need to find side C. Now the easiest of those three things to find should be angle C. We've already got two of the angles, and hopefully we remember that the angles inside of a triangle are supposed to add up to 180 degrees. So if we take 180 degrees, subtract away the 48, and subtract away the 36, then we should get angle C to be a 96-degree angle. So I'm going to label that in here, 96 degrees. Now we need to start taking a look at finding our missing sides, so either side B or side C. Now as we take a look at what we've got, we know the measure of angle A and we know the measure of side A. So I'm going to use those two pieces to help me out. And let's maybe start with finding side B. So what I can do is I can take side B, which is unknown right now, divided by the sine of angle B, which is 48 degrees, equals, now I'm going to set up a proportion where I know both pieces of information. And we said we already knew that side A was a length of 8 because I put a side on top of this fraction. I need to put a side on top of this fraction over the sine of angle A, which is 36 degrees. Now, if I want to solve to get B alone, right now we're dividing by the sine of 48. So what I'm going to do is multiply that sine of 48 over to the other side. And then if I rewrite my fraction in here, since I'm multiplying by the sine of 48, that's technically over 1. So if we multiply the top of our fraction together, I'm going to get 8 times the sine of 48 divided by the sine of 36. Now we should be able to type this into our calculator. We do have to be a little bit careful though, because these are degree angles. We do need to make sure that we switch our calculator into degree mode. Now I'm going to go to two decimal places on my answer. So if I take 8 times the sine of 48 and divide that by the sine of 36, we should get our B side to be about 10.11. Now we're going to do similar things to help us find side C. So what I'm going to do is take side C over the sine of angle C, which we found earlier to be 96 degrees, equals, now I'm going to use that information about side A again, so I'm going to go length of 8 over the sine of 36. Again, I want to solve to get C alone, so I'm going to multiply that sine of 96 over to the other side. And again, I'm going to rewrite my fraction. So we're going to have c equals 8 times the sine of 96 degrees divided by the sine of 36 degrees. And I'm going to type all of this into my calculator. And again, I'm going to go to 2 decimal places. We should get about 13.54. And I'm going to label those sides on my triangle. Earlier we said B was 10.11, and then we just got done saying that C was 13.54. So we have solved this triangle because we found all of the missing information. That's going to be it for this video. Thanks for watching.